Hello Internet, welcome to yet another video on microcontrollers. In this video, I'll discuss the memory of 8051, the programming model of 8051. 8051 being the most basic microcontroller is supremely important to understand, and it forms the foundation of understanding the working of microcontrollers and ARM processors at a later stage. Now, we know that memory of 8051 or programming model refers to the internal RAM, internal ROM, and the constituents of special function registers. They together form the programming model. Now, in 8051, the internal RAM is 128 bytes, and going by the rules of finding the addresses for this internal RAM, they'll come out to be from 00H to 7FH. Now, I highly recommend you watch my video on the same series where I explain how to calculate the memory addresses of a particular memory of a specific size. So I'll not be discussing how I calculated the address range from 00H to 7FH for 128 bytes memory, but for the time being we take it for granted, and we know that this is the memory which is accessible to the user in 8051. Now, if we draw this memory space, of 8051 ranging from 00H to 7FH, which is of course 128 locations. Now, these 128 locations are further divided into three parts. The first one being register banks. Excuse me. You need to understand that the total memory of 8051 is divided into three parts. The first part is a set of register banks. There are 4 register banks, and the names are register bank 0, register bank 1, register bank 2, and register bank 3, and all of them are 8 byte long. So it wouldn't be tough to comprehend that the first register bank would start from 00H and would go up to 07H. So there are going to be 1, 2, 3, 4, 5, 6, and 7 registers in the first register bank, and from 08 to 0F, from 10H to 17H, and from 18H to 1FH. So I've divided the allocation for 4 register banks. So all in all, the register banks will start from 00H and will go to 1FH. There are 32 registers in these register banks register bank 0, 1, 2 and 3. Now the second part is the bit addressable area. And it has 16 registers. So obviously it'll start from 20H and it'll go up to 2FH. So there are 16 registers in this area. Now what is special about this area? All the registers in bit addressable area are those registers whose individual bits can be addressed. For example, first I'll draw the bit addressable area separately. So all in all we have 16 registers. Now, the specialty about these registers is that all the registers have bits which are individually labeled as a number. So the bits inside the first register are labeled as 00H, then 01, 02, 03, 04, 05, 06 and 07. So each and every bit in this register is given an address which is hexadecimal in number, and 21H register will have the addresses starting from 08, 09, 0A to 0F, and similarly will proceed with 10 to 17, 11 to 1F and so on. Now there are 16 registers and 8 bits in all of them, so there are 128 bits in this region, and if you keep on labeling them continuously in this fashion, you'll end up having an address space of 128 bits with all the bits labeled from 00H to 7FH. So it is very important to make a table of all these bit addressable area registers, and you should know that 2F register, for example, have bit addresses ranging from 78H to 7FH. Now the third part, which starts from 30H and extends up to 7FH, is the byte addressable area or general purpose area. So that is how the internal RAM of this microcontroller 8051 is organized. It is organized into 3 parts: register banks, bit addressable area and general purpose area. Now beyond 7FH there is an area now on top of this RAM, if we place this extended area whose address space will start from ATH, and because of 8-bit data bus it can only go up to FFH, which is another 128 bytes of space. Please understand, this 128 bytes of space is that space which is accessible to the users. Each and every register of this space is accessible to the user. But this extended space starting from ATH to FFH, which has 128 bytes or 128 registers, will only have 21 registers which can be accessed by the users, and those are scattered all over the place. Now within the range of these addresses ATH to FFH, we have a list of 21 SFRs. Now you could pause this video and note down the register addresses. I've tried to arrange the registers in the ascending order. It is starting from ATH, then this register signifies port 0 of microcontroller, and the next register 81H will be the stack pointer. You can see that starting from 80 we have 81, 82, 83, then 84, 85, 86, 87 are missing, so those registers are not accessible. We cannot see them, we cannot access them. Then we have 88 somewhere here. So you could either draw these SFRs on this extended memory set with some amount of spacing which is kind of not accessible for better understanding. So if we have something of this sort, it is more easier to understand. So you know that this space is of no use to us. So 88H, then we have 89, which is again a special function register, then 8A, 8B, 8C, 8D. Then if you notice, 8E and 8F are not accessible. I'm sorry, I missed out on 87, so 87 is also here. I missed out here also. I remembered all the SFRs, but I missed out on this one, so you insert this 87 over here. And after that, after 8D, the registers are placed sparsely. After 90H, you'll find a special function register at 98H, 99H, and then you have a space. Then you have another space which is not accessible. So out of these 128 bytes, you should remember the locations of all these special function registers. A lot of people classify these registers based upon their functions. For example, they would put ATH, 90H, A0 and B0 into one set of registers for ports, and similarly they'll put another registers like TH1, TH0, TL1, TMOD, TCON into registers associated with timer and counters. but that way I think it is not easy to remember their addresses, because I'll touch upon a point now. Now, out of these special function registers that I've listed here and here, these are 21 in number. I'll mark down those registers whose address is ending with either 0 or 8. So SFRs whose address ends with a 0 or an 8. So let us mark down those registers. I'm marking those registers which are ending with 0 or an 8 with a star. Alright, I think I've marked all the registers which are ending with an 8 or a 0. Now all these registers which are marked with a star are bit addressable. Now if I write these registers 80, 90, there's going to be 88 also, then 98, A0, A8, B0, B8, D0, E0 and F0. So there are 11 registers which are bit addressable. How would you find the addresses of the bits inside these registers? It is again super easy. If you make a register in front of the register 80, it will have 8 bits, and you simply write down the first number in the first place of the bits, and you simply start incrementing, and they become the addresses of the bits inside these registers. I'll take up a random example, A8. So you first draw a register and write down A8, and then it will be A9, A0, AA, AB, AC, AD, AE and AF. So that is how you label the bits inside the bit addressable registers in SFR space. Very easy. So if you were to make the register 80 as all ones, that will make the bits 80, 81, 82, 83, 84, 85, 86 and 87 as all ones. Or you could make an individual bit 1 or 0 depending upon your requirement, which is very useful in microcontroller programming, and we'll study as to how we manipulate bits in bit addressable space in microcontroller to perform numerous operations and customizations. By the way, this function was not there in microprocessor 8085. If you've been watching my series on microprocessor programming, you did not find any internal register in microprocessor with this ability, except for the fact that accumulator is used at times as a special function register, but the ability to store a bit individually is not there. So super important function, bit addressability, is there in microcontroller. That was it for today's tutorial. I wanted to touch upon the structure of the internal RAM and the extended area, which features all the SFRs. I wanted to discuss the bit addressability of SFRs and their location in the extended memory. And I hope you liked the video and it was of some help. And if you found this video helpful, and if you found the series of videos that I'm making helpful, then please consider subscribing to my channel. That helps a lot, that means a lot. And you have a good day and a good life. Bye.